Happy Easter to those of you that are celebrating Easter today. Oh, Georgie doesn't like those bunny ears. We are getting into Module 5. This is our first lesson. It's going to be awesome. In our first lesson, Georgie does not like those. In our first lesson, we are going to be exploring volume. So we're going to be using some manipulatives in class. We're going to be using these cubes and really kind of exploring and investigating exactly what volume means. So here we go. Guys, I've been working for a while, and for some reason my pen is not drawing on PDFs. It's the strangest thing because it will draw on other websites, but for some insane reason, it is not drawing on, I cannot draw on our problem set. So we're just going to talk this through, and I'll use this little X as a guide. I've restarted my computer. I have done everything I know how to do. So let's just make the best of this. Okay, so tomorrow in class, on Monday, we are going to be using snap cubes to make these shapes, a variety of shapes actually. I should say figures. And we're going to put together the figures, and then we need to determine the volume. We're not going to use any fancy rules. We're not going to use any equations. We're just going to think and look and explore what volume really means. What you guys need to remember when we're looking at pictures in our work, we'll be looking at pictures like these in our homework, problem set, and I'm pretty sure even on our assessments. What you need to know is that the rules of gravity apply. In E, for instance, do you see this block right here? I wish I could color it in, but I can't. This block right here. It is not floating in midair. When you see a figure like this, you must apply the laws of gravity to figures like this, and you must understand, I know you guys already understand how gravity works, that in order for this block right here to be there, it has to be resting on a block beneath it. I know that seems kind of obvious, but it can sometimes be a little confusing when we're looking at larger and larger figures. You must understand that this back row here in F, that back row, although you can't see the bottom level of the far back, you must know that this top level is all resting on the first floor. We'll call this, I wish I can color this in, we can call this the first floor. You can see that the second floor is intact because the first floor is the base. Okay, so let's just look through A through F here and look at A through F, and we'll talk about the volume. So volume of A, all we have to do, you guys, is count the cubes. The volume of A is 1 cubic centimeter. I wish I could write that. I can't. It's very frustrating, but I'm going to be patient. Please, when we're looking at volume, do not count the faces. This is a face. Any flat side is a face. Don't count the faces. Well, here's 1, 2, 3. No, you have to count the entire cube. How many cubes make up this figure? Well, 1. Okay, sweet. Now let's look at B. Now let's kind of check out, and this is three-dimensional, of course. Let's check out this three-dimensional space, and let's determine how many cubes it takes to make up this figure. Well, we have 3 on the bottom and 2 on the top. So the volume of B is 3 plus 2, 5 cubic centimeters. It's a lot less fun without color, I must say. Let's look at C. Okay, so we have a 1, 2, 3-story building, if you will. We have them clearly stacked one on top of another. Each level of the building consists of 1, 2, 3 cubes. So if the building is 1, 2, 3 stories high, and each story consists of 3 cubes, our volume here is 9 cubic centimeters. Okay, let's look at D. This is where we're going to have to think about gravity and how gravity works. Let's first assess the first floor. So the first floor consists of 1, 2, 3, 4, 5 units. The first floor consists of 5 units. We have 2 on the first floor here and 2 on the first floor here, and they're connected by 1 cube. So we have 5 units on the first floor, and then we go upstairs and we have 6, 7, 8, 9. So the volume of this figure is 9 cubic centimeters. So this isn't a regular shape, so you really have to be careful when you're investigating how many cubes make up this figure. So now let's look at E. So we have another kind of regular shape. This is a 2-story building. The first floor I see is 1, 2 wide and 1, 2, 3 long. So the first floor is made up of 6 cubes. This is a completely flat second floor. So we know that this completely flat second floor relies on a completely flat first floor, because otherwise, if we had any missing pieces in here, this second floor would not be lying perfectly straight. So we have 1, 2, 3, 4, 5, 6 on the second floor, 1, 2, 3, 4, 5, 6 on the first floor. The volume of this shape is 12 cubic centimeters. Sweet. And then let's look at F. We can start from the beginning. Of course, there's more than one way to calculate what the volume is. I think everyone probably will approach it in a different way. I'm just explaining how I look at these shapes, and of course the way you look at them can be totally different, and that's totally okay and totally unique to each person. So we have a 2-story building, and this is a very regular shape. I say it's very regular because it's rectangular, we don't have any holes. This shape up here in D is not necessarily regular. This shape here is not regular because we're kind of missing a part. So these sort of rectangular prisms are very regular shapes, but we still must pay close attention when we are trying to calculate the volume. So let's look at this from the second floor. The second floor consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes. That's the second floor. And because this is a regular shape, we know that the same 10 cubes are holding up the second floor here on the bottom level. So we have 10 cubes on the bottom level, 10 cubes on the top level. 10 plus 10 is 20. We know this figure is made up of 20 kiddos. Since my pen still isn't working, I'm just going to give you a preview as to what we're looking at tomorrow. So tomorrow in class, we're going to be working with this dot paper. On this dot paper, you're going to be drawing a variety of figures, and you're going to be drawing figures that have various volumes. This figure, of course, has a volume of 4 cubic units because this figure is made up of 1, 2, 3, 4 cubes. Okay, pretty cool. Let's look at this problem number 3. So Joyce says that the figure below, this one right here, made of 1 centimeter cubes, has a volume of 5 cubic centimeters. Explain her mistake. Okay, well, let's just count what we see. I see 1, 2, 3, 4, 5. Okay, yes, Joyce, I see 5 centimeter cubes, but Joyce is forgetting about our friend named gravity. Gravity prevents this cube to be floating in midair. Joyce, don't forget that in order for this cube right here to be there, it has to be held up by a cube underneath it. So that means on the first floor of the building, we have 1, 2, 3, 4, 5. 5 on the first floor and then 1 on the second floor, Joyce. So we're actually looking at a volume of 6 cubic centimeters in this figure. And you know what, guys? That's going to be it for today. Sorry about my problems with my pen. Hopefully that will be solved tomorrow. I really hope you guys enjoy your day today and can't wait for the beginning of Module 5 tomorrow. That means new problem sets, fresh starts. I think a lot of you have been looking forward to this module, as have I, and I'll see you guys then.